Good afternoon, everyone. It's a pleasure to be here. This is an amazing event, and of course, brings new information and scientific information that we are developing in Brazil. It's fantastic. It's an honor to be here. Today, I will talk about a quite simple issue, since I believe all of you know about coffee processing. However, I try to bring some lights or highlights about coffee processing and technology, and maybe encourage you to open a good discussion about old paradigms. The most traditional wet processing in the world requires around 3,240 liters per bag. It's around 850 gallons per bag of green coffee. This is an astounding number. To give an idea how astounding it is, if all producers from Colombia, for example, use this process or this method, it would result in 36 billion cubic meters of wastewater. Of course, it's not true. Since most small farmers from Colombia use technology that requires around 400 liters per bag, this is a significant reduction. Moreover, new technologies developed by Senecafe propose or reduce the water requirement for wet process. All these technologies are already being used in different countries, in Africa, Central America, Colombia, and also in Brazil. These technologies reduce 80% of water requirement. This is a huge contribution of technology to save water. To give a general idea about the contribution of these technologies, if currently, according to Senecafe data, 50% of small farmers in Colombia use these technologies, and it saves annually 18 million cubic meters. This amount of water is enough to supply a city like Cali with 2 million inhabitants. This is a huge contribution, and we have to take it in account when we start to discuss about coffee processing. Besides, other kind of technologies like Pulped Natural and Natural requires even less water. In this case, for example, Pulped Natural, it's possible to produce 1 bag of green coffee using only 48 liters of water. And natural coffee. Here, of course, it's possible to produce coffee, specialty coffee, without water. We can save a lot of water and eliminate wastewater with change in the way we process coffee. However, until today, some people still have questions about quality and consistency of the most environmentally friendly coffee process. Yes, I'm talking about mechanical demucilaging coffee and naturals. So naturally, the question is, does mechanical demucilaging process reduce the quality of coffee beverage? These data were collected from Senecafe. I visited them last year. And according to Senecafe data, there is no difference or significant difference between natural fermentation and mechanical demucilaging coffee. We have collected samples in the last 5 years using different coffee processing methods. And I realized that during this visiting in Senecafe that we have exactly the same perception or the same opinion. It's possible to produce high quality using mechanical demucilaging process. This is what Senecafe has to say about their coffee. And we have also our experience in Brazil. And according to our experience, the most important factor is the interaction between genotype and the environment. It's necessary to remember that different genotypes can respond to environment in a different way. I mean, according to genotype, in different environments, it's possible to obtain different results in coffee quality. I believe that it's necessary to understand that the contribution of processing, it's not to change completely the coffee quality and cover the quality that comes from the interaction of genotype and environment. The coffee processing should be used to emphasize the quality as a result of interaction, genotype, and environment. So, at this point, I believe that we agree that all coffee processing method may result in specialty coffee. So the question, it's not about any specific coffee processing method, but how coffee is treated. So the question is how coffee should be treated to ensure that any coffee processed by any way can have quality and consistency. Many people until today believe that the differences in the coffee quality from different coffee processing is associated or depends on the amount of sugar that moves from mucilage to seed. It doesn't make sense. Sugar is a soluble molecule. How a soluble molecule can move in a different direction, I believe that the explanation goes far beyond this simplistic explanation. In nature, there are different seeds, and seeds with endosperm, for example, corn and coffee. Here, behind me, there's a beautiful picture of endosperm of corn. Here it's possible to see cell wall and starchy grains. However, it's not possible to see the membrane, the cell membrane. It means the corn endosperm is a lifeless tissue. It is physiologically inert. Most part of this tissue is lifeless. However, coffee endosperm is a living tissue. It's different. It is endosperm, however, it's living tissue. What it means, it's physiologically active. Different reactions, like enzymatic reactions, respiration, and different metabolic routes may occur and change completely the final coffee profile. However, when the cell membrane loses its integrity, the cell content has contact with oxygen. Now, oxidation, resulting in different off flavors. Cell integrity is the key for coffee quality and consistency, considering the point of view of coffee processing and post-harvest. Let me try to help all of us to understand better how cell membrane can be preserved. It's necessary to talk about an interesting phenomenon that occurs in nature, called as anhydrobiosis. Anhydrobiosis means life without water. It occurs in different living organisms. In plants, it is associated with desiccation tolerance. An interesting aspect is this tolerance depends on protection from sugar molecules. Let me try to explain better this concept. This is a schematic representation of the cell membrane. This is a phospholipid bilayer. The blue part or bluish part of this membrane is hydrophilic portion or part. The orange part is hydrophobic part. It means to maintain cell integrity, it's necessary to have water outside and inside of the cell membrane. However, coffee is a drier tissue. So how it's possible to maintain integrity, cell integrity, without water? This is anhydrobiosis. This is beautiful. What's happened? During drying, the water is removed, of course, and glucose and other sugar molecules replace the water molecules and maintain and preserve the cell integrity. However, when this substitution doesn't occur in a suitable manner, the membrane loses its integrity. It will result in inconsistency. I'm not talking about defective beverage or defective coffee. I'm talking about specialty coffee with consistency and high quality. So, cell membrane integrity is a key to maintain or to ensure the coffee quality and consistency. Here we have two beautiful pictures. This picture here, it's possible to see the cell wall in the lighter colors, bluish colors, membrane, and the orange part represent the oil into the cell, inside the cell. It means it's preserved. It is a specialty coffee with high quality and consistency. It was dried with right temperature, right conditions. However, in this other picture, it's possible to observe or to see that the oil is outside the cell. It was dried with 60 degrees Celsius. It means the cell wall or the cell membrane loses its integrity. Maybe you have had this experience cupping some samples or tasting some samples, and 1 or 2 cups with oily taste or rancid taste. Oh, the problem is with the roaster or the drying curve, etc. No, probably you are cupping this kind of sample. Other interesting situation, you are roasting 2 samples with the same origin, the same variety, with exactly the same density, using exactly the same drying roast. However, one sample has more oil on surface of roasted coffee than the other one. Maybe this is a very important way to explain this difference. It means inconsistency. This sample will lose quickly the quality during storage. So, I cannot understand why the quality is decreasing so fast. Maybe we are talking about samples like this. Here we have another 2 pictures, interesting pictures, exactly the same samples, however, using different methodologies. Here we have vesicles. These technologies allow us to analyze inside the cell. It means we have vesicles preserved. And here we have a coalescence of vesicles in consistency with high quality and consistency. So, as a professor, I love questions. What's the next question? What caused this kind of rupture? What kind of a process is more sensitive to thermal damage from drying? This is an important question. Over several years, we have observed that natural coffee is more sensitive to thermal damage than washed coffees. Yes, I will repeat. Naturals are more sensitive to thermal damage than washed coffee. It's necessary to understand how important is this information because it can help us to produce natural coffee or natural coffee with consistency and high quality. This graphic, it's possible to observe or to see that the germination of washed coffee is pretty high, and the germination of natural coffee is less than washed coffee when sun-dried, and when we used heated air, the germination of natural coffee was 0. The first time that we collected this data, I said to my student, I'm sorry, you have to do everything again. It's not possible, it's wrong. Poor student. Again. After 5-7 years, exactly the same result. Using other approaches like enzymatic activity, this is germination just an example. To open this discussion, it's necessary to reveal this old paradigm. It's very frequent to find in different literature, books, etc., recommendation that you can dry natural coffee with higher temperature than washed coffee. It's not true. Not for specialty coffee. It can be true for commodity, but we are talking about specialty coffee. For specialty coffee, it's not true. However, you can ask me, Professor, so natural coffee cannot be dried with heated air? No, it can be. However, we have to know how to dry natural coffee. In addition to sensitivity to thermal damage, coffee is also sensitive to drying rate. This is an important information, really important. Why? Because most coffee producers in the world are trying to reduce the time of drying. So it's necessary to increase the velocity that we remove water from the coffee. It means drying rate, grams of water per kilogram of coffee mass per hour. However, as natural coffee is sensitive to thermal damage, for specialty coffee it's necessary to decrease the temperature. It will increase the time of drying. So, let's do something to reduce this time. Let's reduce the relative humidity. Or let's try to use environments with really low relative humidity. We studied this effect of drying rate on final coffee quality. And we dried natural coffee under controlled conditions and different drying rates. To do so, we use the temperatures from 35 degrees Celsius to 45 degrees Celsius and different relative humidities. We have an interesting device in our university, Federal University of Lavras in Brazil, that we can control the thermodynamics properties of the air. What it means, temperature, relative humidity, etc. So we can establish different temperatures, the air temperatures, and different temperature of dew point. The combination of these two temperatures result in different relative humidity. It means we can simulate in our lab different environments. Here you can see the black lines, really high drying rate, and the red lines, low drying rate. What it means? High temperature, low relative humidity, high drying rate. Low temperature, high relative humidity, low drying rate. The increase in drying rate reduces coffee quality. It means if you want to produce natural specialty coffee, it's necessary to use low temperature, below 40 degrees Celsius. However, you have to avoid dried environments. It's really important. On the other hand, washed coffee is more resistant to thermal damage. So, to reduce the time of drying, some producers are trying to increase the airflow. The increase in airflow increase the drying rate, and washed coffee reduce quality. I presented these results in ASIC in Costa Rica. After my presentation, a person here from the United States, he asked me, Professor, so I'm developing a new dryer, and I'm trying to increase the airflow to reduce the time of drying. Well, if you are trying to sell this dryer for specialty coffee, forget it. Because specialty coffee will lose quality with really high airflow. People, help me. Spread this information. Drying method is associated with cell integrity, cell membrane integrity. Cell membrane integrity is associated with quality and consistency. And remember, the temperature should be below 40 degrees Celsius. I recommend 36, 38 degrees Celsius for both natural and washed coffee. The drying rate for natural coffee should never be above 13 grams of water per kilogram of coffee per hour. So it means we have a number. Airflow for washed coffee should be as lower as possible. Have you ever seen a natural coffee like this? It looks like more a dried fruit. This is the right way to process natural coffee. This is a yellow bourbon. Look at its color. It's beautiful. Thank you.